Alright, the first thing we're going to do is test the buoyancy of an object. Start by dropping a ping pong ball into the pool. And you notice how first it goes down into the water until it displaces its weight of the fluid around it, which causes it to float. Less dense objects has a greater buoyant force and will float more than an object with that's more dense. Alright, now we're going to test the gravity of an object. Now to drop this ping pong ball, it will fall at 9.8 meters per second, every second. So two objects with different masses, like this tennis ball and ping pong ball, will fall at the same rate, no matter the mass, neglecting air resistance. And they fall at and they hit the ground at the exact same time from the same height, because gravity is constant. Bang. Now we're going to explain Newton's first law of motions, which states an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted on by an outside force. So here we have a tennis ball that is at rest, and over here we have a ping pong ball that I'm going to exert a force on. As you can see, the ping pong ball continued rolling, and if friction was not involved, it would keep rolling forever until
it hits.
Forever, non-stop, and this tennis ball will remain at rest forever. So the equation for Newton's first law is if the F equals 0, then A equals 0. So if the force equals 0, then the acceleration equals 0, which is the ping pong ball. Now I'm going to show you the physics in tennis, which is when the tennis racket creates a friction on the tennis ball when hitting a shot. Now when I take the tennis racket and I brush over the top of the tennis ball, it creates a topspin that makes the ball move up and towards your opponent, while if I put a backspin on the ball, it'll do the opposite, and it'll go downward and away from your opponent. Now I'm demonstrating the angular momentum of a ceiling fan, which the fan blades are rotating around an axis of symmetry. Therefore, the angular momentum of the ceiling fan can be expressed as the body's moment of inertia and its resistance to change rotation.